Yeah, we're already rolling. I got that. So.
Hello, race fans. It's Peter Partee from Partee Racing. I'm here with Chris Knerr, my lead designer, who also is our lead carbon fiber fabrication specialist. And he is the designer of our S62 carbon fiber plenum, top and bottom. And so it came to light recently in connection with a post on the E39 and 5 board that a lot of people didn't understand the functional superiority of our piece. I mean, clearly it is a hot looking piece, Chris. You did a great job. I mean, this is beautiful, right? I mean, this is prepreg carbon fiber, right?
Yeah, that's correct. 100% prepreg, sourced from England. Formula One quality stuff. It's UV stabilized out of the box. In addition to the UV stabilization that comes from the clear coat, it's as good as it gets.
And baked in an autoclave.
Correct.
Tell us a little for a second, what is that?
So an autoclave, essentially, in the most layman terms I can come up with, is it's a giant pressure cooker, right? So normal carbon fiber processes traditionally have been wet lay or vacuum assisted wet lay, which is where you use a liquid resin, you lay it on with a paintbrush or a roller, and you smooth it all out, you saturate the carbon fiber with it as you're in situ. Whereas with prepreg, the carbon comes pre-impregnated and activated with epoxy resin. It needs to be kept frozen because it's always curing. At room temperature, as opposed to traditional wet epoxy, prepreg will cure over the course of about a month or so. And to say it will cure in a month is a stretch. It becomes kind of crunchy, right?
Got it.
But not all the way solid. Whereas a traditional wet lay stuff will cure over the course of about 24 hours typically at room temperature. Prepreg needs high temperature to cure in...
What kind of temperatures and pressure are we talking about?
So we're talking about 250 degrees Fahrenheit and about 132 PSI, 9 bar.
And how long are you required to bake it for that?
So it bakes in the autoclave for about an hour and 20 minutes. We usually go a little bit beyond that just to account for anything that's caused by like the mass of the mold, keeping temperatures down. We want to... You can't overbake it, but you absolutely can underbake it to the point where it doesn't reach its full cure properties.
Got it. And what impact does that have on the strength of the carbon fiber?
Well, the big thing is the pressure on this in terms of strength at regular temperatures, right? So the big advantage of an autoclave over vacuum-assisted composites processing is you get more crush, right? You know, if you look closely at carbon, you can see the individual threads, the toes of carbon that are going through it. And the more they are crushed into each other, the harder it is for it to slip across itself. And that's where the strength of composites comes from, is that rigidity caused by the carbon not being able to move within the epoxy matrix.
Got it. So this is not just a pretty face, it is also strong as it can be.
That's absolutely correct. It is as good as it gets.
And super lightweight. I know people are always shocked at how lightweight it is compared to the stock plenum.
Yeah, I think we weighed it a while back and something like 73% of the weight was the billet.
Yeah.
The carbon element actually weighs almost nothing by comparison.
There you go. And this billet ring is made out of what?
It's 6061 aluminum, standard billet material that's really good, and it's lighter than 7075, but it's plenty strong for what we're doing here. I mean, you know, the stock piece from BMW is either cast aluminum or plastic, so this is more than strong enough for what we're doing.
And how do you adhere the carbon to the billet, Chris?
So we use methyl methacrylate adhesive, MMA adhesive. It has really good properties that lend it to a carbon over aluminum bond. You know, the problem with bonding carbon to aluminum is that aluminum has a much higher CTE than carbon.
CTE.
It's coefficient of thermal expansion. So, you know, it's measured in like parts per million or a certain amount over across a meter per degree Celsius.
Right.
Carbon, especially prepreg carbon, because the specific epoxy that's used is paired with a specific type of carbon, because not every toe of carbon is created equal, right? So the manufacturers of prepreg in particular will pair epoxies with certain carbon fabrics to end up with a 0 CTE, right? It does not expand or contract with temperature. And so this doesn't move at all, no matter what temperature it is, but the aluminum moves quite a bit in comparison. And so you need an adhesive in between the two that actually can tolerate that.
Got it. And MMA does that.
Exactly.
Got it. Okay, so and then these are adhered with, we know, titanium bolts that I picked out because They look cool.
Hey, Peter's got to be fancy.
I couldn't resist. I had to contribute something here, right? And so now let's talk about the function of this thing.
Right.
This is not just a copy of the stock S62 Plenum.
No, absolutely not.
How is it different?
So they're in several ways, honestly. On the top here, we've deleted the M logos and all that stuff, mostly because we prefer the clean look.
Sure.
We think it looks a lot more elegant, a lot more race car. Honestly, there's no flashing here. But also, if you notice these ridges here, they're strategic, right? Because the place that we have the most trouble with height in our plenum, or over our velocity stacks, is right here, where the velocity stacks are curving in towards the center. By raising this just a few millimeters, we actually gained a lot in a very tight space.
And you did away with the stanchions here.
That's
here.
correct.
There were 4 of them. Why don't you need those?
Well, the carbon is just a lot stronger than the plastic. That's really all it boils down to, is that this can handle the pressure that you put into it without breaking a sweat. It also helps for acoustics. We gain function over form is always the mantra around here, but in places where we can gain some form with function, we like to. And by losing the stanchions, we gain some better acoustic performances, which means the induction noise is just that much crisper, that much louder. You can really hear it in the car and really enjoy it.
You've got greater volume in this.
Exactly, that's
airbox
correct.
as well, right? I mean, if you flip it up right here, this bolts directly to the throttle bodies with these very thin composite gaskets, right?
Right.
And so because of that, you don't have that space that's taken up ordinarily by those thick rubber, ridiculous gaskets on the throttle bodies. Instead, you were able to make this deeper.
Yeah, it's pretty significantly, not just in this area, everywhere, right?
Right.
Like we had one guy point out that this part, because it's flat, he thinks that we've actually reduced the amount of volume in the plenum, but what he doesn't realize is everything is lower. And so this part looks higher relatively.
It's a lower floor altogether.
Exactly. I was able to drop here about 20 mil, if I remember correctly, and then everywhere else we used our 3D scanner. We 3D scanned the top of an engine, and I lowered the plenum everywhere. And so with that, we were able to gain about 20% of overall volume, and in really useful places too.
There you go. There you go. So again, you have more air volume. That means more power, clearly, in a naturally aspirated context.
Yeah, there's more air to scavenge from, right? Like every single time an intake valve opens and pulls air in, you get a major negative air pressure zone around the end of the stack. And by increasing that volume, you decrease the total static pressure drop inside the plenum, resulting in more filling of the cylinders.
And this carbon fiber doesn't retain heat the way the stock aluminum piece would, correct?
No, that's correct. It is more reflective of heat, and it doesn't reject heat to the inside as much as aluminum does, nor does it soak with quite as much energy overall.
Got it. So you have less heat soak, and you got more air capacity. And you can fit our velocity stacks. I see you over there fondly.
Yeah.
Tell us about those.
So this is the first project we ever worked on together, actually.
Way back when.
Yeah, we're on version 6 of these now. We're on version 6 of these now. The first iterations we were trying to do carbon bases with, and that just didn't quite work out. And we can keep and delete as much of this as you want, Peter. Off topic.
I think we're going to keep this piece.
And then we pivoted to using the aluminum bases, and we had some trouble with how we were actually adhering them together, and we had several failures, and we recalled pretty much everything as I remember.
And it's good to point out what was happening is that we didn't have enough material for the area for the aluminum flange to adhere to the carbon fiber with the MMA inside. And so how did you cure that, Chris?
Well, as you said, initially we were just kind of setting the carbon into a groove around the top of the flange.
Right.
And then we were using the MMA to adhere it in, and then additionally we were using the MMA to actually smooth out this contour so that way air could flow, because if without it there was a lip that was created by the carbon, or by the billet inside the carbon. Eventually what we decided to just remake the molds entirely, which was expensive and time consuming, but we actually choked down the carbon a little bit to where the inside of the carbon is where the previous inside of the billet was. And then we bored out the billet section even more so that way the carbon could slip down inside of there. And then we get about a 1/2 inch of slip, which if you know anything about adhesives, adhesive is very weak. Adhesives in general are very weak in terms of lifting or peeling forces. So when you're trying to pull it out like that or tilt it where it peels the adhesive out, that's the weakest possible way to use adhesives. What we've done now, and editor B-roll this in, you'll be able to see that the carbon goes all the way down to the bottom of this billet section. And so now all of the load on the adhesive is in shear rather than in peeling or lift. And shear is the absolute best way that you can use any adhesive, because trying to get this to pull, the carbon will fail before the adhesive will fail.
Those were the initial failures that we had, is when we were just sticking it down to the groove. You know, you've got some guys jamming it into their throttle bodies and pushing on it, trying to get it in the hole, and it would cause them to wobble or pull up a little bit. Now, there's absolutely no chance of that happening because there is so much carbon that is adhered to the inside of the billet flange with MMA. I mean, it's a good, what, you said 1/2 inch?
Yeah. It's actually slightly over 1/2 inch.
Yeah, I mean, you know, there's just no way that's coming apart now.
Yeah, that's correct.
In any event. And so let's talk about the design of these. I was all hip on ensuring that the bell mouth was a 180-degree bell mouth. And you were pretty skeptical about that at first.
I was actually. I was very skeptical initially because it created a lot of extra cost. It meant the molds had to be more complex to actually get that in there. But after I did the first set of these, after I made the first set of these with the full 180-degree bell mouth, I was in the paint booth and I was spraying them, and I was holding it like this, and I was spraying from this direction, so the clear coat was going that way. And this lip actually caught and pulled the clear coat around and ended up hitting me in the face. And in that moment, I became a believer. I was like, okay, it's real, it's a thing.
Well, and I have to confess, you know, my mandate in that regard was driven by Dusty Renteria, who I think designed the original stacks for Dynan used on the S2. And he regularly told me, you know, if you make these velocity stacks flat on the edge, it's just going to reduce power. And again, it's a pretty simple concept, right? Because, you know, you're trying to get air in smoothly, not only from directly in front of the horn, but also from the side and from the back. I mean, ideally, it'd be great if we could curl it all the way around, but there is a law of diminishing returns. You definitely want to get air coming in this way very smoothly. And if you have it flat, it's disrupted right around the edge where you don't want disruption. So these guys, we know, multiple clients have proven, I think the minimum horsepower gain we got back to back was 18 wheel horsepower. And the one that I happened to show the very first time, we got 22 wheel horsepower. And then when we tuned them, we got 30. And so, I mean, these clearly make a material difference in power. They are very similar to, but superior to the Dynan stacks. They have a slightly set of different dimensions. Dynan has a stack number 2 that had to be cut on the bottom or top edge in order to fit it. Ours don't, either in the stock plenum or in our plenum, because of their shape. And ours are a little bit different in length and diameter, and they are optimized. We think these are the best stacks you're ever going to get for the BMW S62. And you pair them with our plenum, that additional air volume and no cutting, no conflict in the air. I think you've got the best air box you can get for the BMW S62. Now, one final point, Chris, is I think there was somebody online who was saying, well, we think it's really stupid that the design of the first and fifth stacks are pointed backwards as opposed to front, because that means that the other, 6 cylinders are stealing all the air, and only whatever's left over is going to the other two. Tell me what's wrong with that.
I mean, it just shows a fundamental lack of understanding of how this airbox operates. All things being equal, the airbox, there's a normal pressure inside the whole thing, right? Like it's not there's just enough air coming in through the main inlets to feed the engine. There's more than enough. The surface area of those two inlets is far greater than what you would need inside the plenum. So the plenum always stays a relatively normal pressure. There are going to be very small oscillations as cylinders open and close, but generally speaking, the air pressure here is going to be the same as the air pressure here. And
one stack is not going to be stealing from other stacks.
Correct. Frankly, having all 8 of them pointing together is more detrimental because you have far more turbulence in the area where they're pulling air from.
Right.
Whereas having them all spread out a little bit more is more beneficial in the actual application of the plenum.
Exactly, and this has been proven out with tuning. We've never had to the extent we even could, adjust on a cylinder by cylinder basis for relative filling based on the stacks 1 and 5 pointing backwards. And that's of course what would be the case. And if the theory of stealing air had any validity whatsoever.
Yeah.
So look, the 2 of these things together, it's a $6,000 setup. The plenum is $3,250. The stacks are $2,750. It's a lot of coin. We know that, but it is a true performance advantage. The stacks will go with your stock plenum, but if you're going to do the stacks, you really ought to do the plenum too, because boy does it look good, and boy does it make power. And then the final note is for those of you out there who always say, "Yeah, but what about the sound?"
It sounds incredible.
The induction sound, we put these on all of our top builds that we renovate here in the shop, and oh my gosh.
Anybody who hears it in person cannot believe the difference.
The intake sound of the S62 is already just phenomenal. You add this to it, it is the best I've heard. And we also do a plenum. Obviously, we'll do for another video for the S65.
Yeah.
And from your car, you have an E92 M3.
Yeah.
That plenum in your car, just wow, does it wake up the intake sound?
100%. I was skeptical because the S65, the E92 already has an incredible induction noise out of the box, and so I didn't think it would make much of a difference going to carbon. And then we put the airbox in on my car to test, and I couldn't believe it. It sounds incredible. Everybody who rides in the car, it's the first thing they notice.
Well, there you have it, folks. Again, this exemplifies the approach that Partee Racing takes to the products that we manufacture. We only make products when we think we can make them better than what's on the market. And here we felt like we could make them better. Made them better functionally, aesthetically, in terms of heat management, lightweight, in every respect. They're worth every dollar you're going to pay for them, I promise.
There are no compromises on this part.
As you like to say. Thanks, everybody.